Can everybody see the screen?
Yeah, we're
I can
good.
see it.
Okay, great. I want to welcome everybody. So today we're gonna be debusting myths. So like we're gonna addressing every like neuroscience misconceptions. So first off, I want to introduce myself. So my name is Thurleen, and I'm the founder and the president of MedMind.
And I'm Shreya, and I'm the head of the writing team.
So we are part of MedMind, an organization dedicated to helping people stay informed about latest developments in medicine and spreading medical awareness to better assist people in making educated decisions regarding their health. So like every month, based on our chosen theme, we publish like 3 or 4 articles under our blog. So you can like see our websites on our Instagram, it'll be in our bio. And then, yeah, so these articles are written by our writing team. So every month we have like some theme, like for one of the March month, it was like neurological uh, diseases. So today we want to delve into like the fascinating realm of neuroscience, a field that has like been captivated our emotion and continues to unravel the mysteries of the human brain. So, but however, amidst like these awe-inspiring discoveries, there are like several myths which we want to like help debust. So we're going to be exploring such 8 myths. One second, sorry. Okay. So the first myth is that we use only 10% of our brains. So the human brain houses like incredibly complex and advanced functions, but do we only access a fraction of it? So this is actually one of the most pervasive myths is that we use only like 10% of our brain. So this myth has been shown continuously in movies, books, and self-help seminars. So is it really true? Of course not. So this myth has been debunked by modern neuroscience through various imaging techniques, such as functional magnetic resonance imaging, which is fMRI, and position emission torn tomography, PET, so which is PET. These technologies allow researchers to observe brain activity in like real time. So studies using these technologies have shown that even during like simple tasks we're doing, like such as reading or even resting, we're actually using like most like a good degree of our brain. And it's actually kind of higher than our 10%. When we do more complex activities, more parts of our brains are being used. So additionally, neurological injuries or disease may affect specific brain regions or like specific like impact giving like significant impairments, but most of the time we are not using just 10% of our brain. So give me a moment. Okay, so moving on to myth number 2 is that drinking alcohol kills brain cells. So when it comes to our brain, I know a lot of people, not right now me, but we drink like a moderate amount of alcohol and nearly every part of our brain matter is negatively affected, but resulting in like really short and long-term implication. But does it really kill brain cells? There is a difference between affecting it and killing brain cells. So, despite alcohol causing brain damage, it does not really kill our brain cells. Alcohol is kind of like a neurotoxin that can disrupt the communications of the brain. It also affects the functions of the brain cells. This can lead to intellectual impairment, headaches, memory loss, slow thinking, slurred speech, and trouble with balance and coordination. So, excessive drinking instead affects your nervous system, causing the numbness and pain in your hands and feet, seizures, and dementia. So, in like, if you want to be more like summarized way, it's actually not going to affect the brain cell itself. It's just going to affect the way the neurons are being passed along in your brain to like relay a message. So, Of course, the ends of the neurons, which are called the dendrites, they become kind of like hard, which is kind of making it harder for the neurons to relay these messages, which is actually the real effect the alcohol has on our brain. So I hope that makes it more clear. I feel like this was actually a myth, which I feel like I've heard more. So moving on to the next myth. Give me a second. Okay. So human memory is like a videotape. So does our brain really capture all of our experiences? So I think like somebody and maybe all of us have really experienced that. Maybe we look back at something in the childhood we did. We don't really remember everything, right? We maybe remember something memorable, or remember something like bits and pieces of it. So does our brain actually remember everything precisely and accurately? So this is false. Our brains do not store our experiences perfectly. We change our memories a little each time we think about them. So remembering an event is not the same as watching it like on a DVD, like over and over again. You may think you did something, but instead maybe you're just thinking it that way because maybe you want that event to have preferred moving that way. And I have personally actually experienced this. I thought I made a better snowman or something. I looked at the pictures of like when I was younger, I made a snowman, looked horrible. So it's like having a performance of like a Christmas carol, like in a theater several times, or like maybe you listen to a song, something so long, like you don't like a specific lyric, you change the lyrics. Sometimes you're just like, huh, that's there. So it's similar, but not every identical each in time, meaning it starts to kind of get like blurred out. Technically, you can say that way. So memories are unreliable. So that's why eyewitnesses sometimes are recognized as unreliable sources in courts. So when there's like a court case, which is maybe like dated back to like 5 years, the importance of eyewitnesses start to reduce as every year goes by. Because why? Memories start to degenerate, technically speaking, because you won't remember it unless it was something really significant. So yeah, this is a very sad myth apparently, because I really wish I did remember everything. Okay, so moving on to the next myth is the Mozart effect. So babies exposed to classical music ends up smarter. Man, do I wish that this was true because, well, I should have been listening to Mozart from the beginning and I would have been way smart. So the so-called Mozart effect implies that babies exposed to classical music improve their intelligence. How much truth is this? Well, sadly, or not sadly, or I don't know, I find it very sad. This is probably like kind of false. So let me go back a little bit. So the term Mozart effect, it was first coined by Alfred A. Tomatis. I hope I'm pronouncing his name right. So he used Mozart's of music as a listening stimulus in his work, attempting to cure various disorder. So this approach was so popularized in a book by Don Campbell, which trademarked the term after 1993 experiment published in Nature, suggested that when you listen to Mozart, it temporarily boosted students' IQ by 8 points. Now, again, there wasn't like any studies conducted. This was kind of just like one thing he saw, and he just saw like a pattern, like, oh, they just boosted by 8 points. However, so see, there's no really evidence to support this idea that playing classical music can help babies become more smarter. However, musics can be used as more of like an environmental enrichment process in babies and could help improve neuroplasticity and cognitive ability. So it doesn't make a person maybe smarter, maybe it can make them more in tune or something like along those lines. Maybe they can improve their musical abilities or something like that. But making them smarter in terms of like academics wise wouldn't really make sense. So even better, maybe try placing an instrument in their hands, it might work. So who knows, it did wonders for Mozart. So moving on to the next myth.
All right, so myth 5 is the brain is hardwired. This is one of the most enduring legacies of the old brains are electrical circuits metaphor. There's some truth to it, as with many metaphors. The brain is organized in a standard way, with certain bits specialized in taking on in certain tasks, and those bits are connected along predictable neural pathways. They're sort of like wires, and communicative in part by releasing ions, which are pulses of electricity. But one of the most exciting discoveries in neuroscience in the past few decades is that the brain is remarkably plastic. Neuroplasticity, as referenced in the last myth, also known as brain plasticity, is a term that refers to the brain's ability to change and adapt as a result of learning, experience, and memory formation, or as a result of damage to the brain. Learning and new experiences cause new neural pathways to strengthen, whereas neural pathways used infrequently become weak and eventually die. For example, in blind people, parts of the brain that process sight are instead devoted to hearing, which I think is really interesting. Okay, and then you can move on to the next myth. Okay, myth 6. Video games rot the brain. So, we often look down upon video gaming, whether it's due to the constant nagging of our parents or its disapproval through media and film. This often leads us to believe that video games are beneficial for us as developing young adults. However, according to recent studies, it's proven that gaming is beneficial for many skills, such as memorization, multitasking, and the ability to strategize. Additionally, video gaming can aid the progression of brain plasticity, which is the rewiring of our brain's connections, thinking, and functioning. This is mostly due to the immediate response of our actions, which adds to the ideas of attentional control and reward processes. Moreover, multitasking is another skill strengthened through hand-eye coordination required to maneuver throughout certain games. The idea of quick observing and quick reacting prepares not only our hands, but our brains for anything that could appear. Although it isn't healthy to constantly be in front of the screen, video games itself can increase our cognitive function. So now you don't have to be guilty for playing video games. All right. So we can go to the next myth, which is memory degradation during old age is inevitable. Inevitable. You know those times when an adult happens to forget something, they jokingly go, "It's my old age getting to me?" Well, this isn't completely scientifically true. Of course, memory loss is a symptom of Alzheimer's or dementia, which are neurodegenerative disorders, but these conditions are not inevitable for all adults. In fact, in some cases, some adults can actually increase their memory through their everyday tasks that other age groups can't do. And then we have our last myth, that there's only five senses. That's right. That myth that you've been told throughout your whole life, elementary school, middle school, you name it, it's wrong. Touch, taste, smell, hear, and see are the main five senses. However, we don't realize the many other concepts connected to the brain. Some examples are proprioception, which is the sense of how our bodies are positioned, nociception, the sense of pain, and even the sense of balance. All these senses also contribute to how our brain functions and thinks. We're not just limited to five senses, we're so much more. So yeah, thank you for listening to our presentation.
If you guys have any questions, do let us know.
Thank you, Matt, Mine, for the sharing and the meets are really interesting, especially the one about maybe um babies and the Mozart effect. Oh, sorry, I forgot to turn on the mic. Like, it's an inspiring sharing. And I like the myth very much, especially the one about the Mozart effect. And if you have finished your sharing, you should always like stop sharing the screen.
Okay, will do. Thank you so much for having us.
We also have like a little to share. So let me also share the screen now. Okay, Hannah. Are you able to see the screen now?
Yep, we can see it.
Yeah. Sure. So today, like, we would also like to share with you how reading can actually benefits the brain. So actually, different habits are related to neuroscience, as our brain is often impacted by what we do. So in my sharing, I would like to highlight three benefits of reading which are related to the brain. So the first one is that actually through reading, our brain can be more activated. Reading can light up our entire brain. According to a study out of Emory University, the deeper readers went into the story, the more areas of their brain activated. This activity can even like stay elevated for several days after the participants have finished a book. So this shows that the more you read, the stronger the complex networks of brain activity becomes. So it can last for like several days and benefits you a lot. What is more, the somatosensory and motor cortex, which refer to the area of our brain that respond to movement, sensations, and pain, can remain active long after a book was finished. And research from a Boston Children's Hospital have discovered that reading can also benefit children a lot, as reading can rewire their brain, create new neural networks, and strengthen the white matter in the corpus callosum, which can enhance communication between two brain hemispheres. This allows children to study better because they can process information more efficiently and learn faster. Besides, reading can strengthen children's and like people's visual and auditory comprehension, particularly if they're like listening to someone reading aloud. And this can also like benefit or maybe exam skills. And what is more, reading can reduce stress level. This is not based on evidence, but it's actually like supported by science. So, according to a 2029 study conducted by Sussex University, readings can reduce stress levels by up to like 68%, and if as little as 6 minutes of being immersed in a book, heart rate can slow down and leading to reduced blood pressure and relaxed muscles. Besides, reading with children can also create a bonding between family members and increase the parents-children bond while decreasing their stress. A 2020 study from the Journal of the American Psychological Association found that parents who read to the children daily from the ages of 6 to 18 months had lower stress and are more sensitive to their children's needs. Plus, become warmer to the children. And the third benefit of reading is that it can help expand our own imaginative world. It is because our occipital lobe is activated, and the lobe is the area of the brain responsible for processing visual information. And a joint 2007 study between two universities found that undergraduate college students who read for pleasure had higher levels of creativity, more positive perceptions of the professors, and are more eager to learn, thus allowing them to achieve their academic goals easier. And another study in the same year also showed a significantly high correlation in college students who reach for pleasure versus creativity than those who don't. So I hope you enjoyed the quick sharing about the benefits of reading, and hopefully you are encouraged to read more. And before this session ends, you could also search Kahoots online, because like I've created a game. It will be like a very short one and will be a recap of what we have covered in this section. Please wait a sec because it's like loading on my side, and yeah. I'm typing the pin in the chat room now. It will be 70784.
What's the pin again?
70784.
Thank you.
Since someone is planning to join the meeting now, so maybe wait for 1 more minute or so. Thank you. Or I think we can start now, maybe. So the first question is about whether video games can rot the brain. And the second is about whether excessive alcohol consumption can kill brain cells. So I think according to the mind sharing, it's mentioned that dendrites will be affected.
I think you have to share your screen, like showing the options.
Oh wait, sorry.
That's okay.
Maybe I could read it out first because it might take some time. I'm so sorry. And the next question is about whether the brain is hardwired, and the blue option with the diamond is true and the triangle is refers to false. And the next one is there are only 5 senses. The blue option with the diamond is true and the triangle option in red is false. The next question. Human memory is like a videotape. It records and remembers everything accurately. And the triangle is true, diamond is false, circle is sometimes true, and square is true to some individuals. As a matter of fact, like sometimes we can actually like remember things accurately, but it's not like every occasion. And some people will compare it to like the videotape. And the next question is whether we use only 10% of our brain. The diamond is true and the triangle is false. And it's false.